Okay, so for 3.5, we're going to be talking about arithmetic sequences and the fact that they are linear functions. So a sequence is a set of numbers that's going to typically have some sort of pattern to it. Today, where it's an arithmetic sequence, that means it's going to be adding the same number each time. Now, here's the secret to arithmetic sequences here. You're never allowed to subtract. So when I look at these two examples here, this first one, I can see that, from 3 to 5, I add 2, add 2, add 2, add 2, add 2. But when I look at the second one, it definitely looks like I'm subtracting 4. But for arithmetic sequences, you're not allowed to subtract. So we need to be creative. You're only allowed to add. So instead of subtracting 4, can I say that I add a negative 4? Okay, this number that you add each time is going to be called the common difference. Right there. Get used to that vocabulary word. We're going to use it this entire chapter, or this entire section. So here where I was adding 2, that common difference is 2. Here where I'm adding a negative 4, that common difference is negative 4. So the first thing I'm going to do is try and figure out the next in the pattern. Or no, I'm sorry, if it's arithmetic. So what I'm going to do is find the common difference. Now sometimes you might be able to see it. For example, I'm actually going to start on 1B. I can look without having to do too much math. I can just see that from 1 to 4, I had to add 3. Okay, from 4 to 9, I had to add 5. And from 9 to 25, okay, maybe now I need to count it a little bit more in my head, but it is 16. A sequence is arithmetic if and only if every single time you are adding the exact same number. So this time I did not add the exact same number, so no, this one is not arithmetic. Now when I look at 1A, sometimes those negative numbers can trip us up a little bit. So a trick that you can do is to actually take the next number and subtract the previous number. So negative 22 minus a negative 26. I have a double negative, so I'm going to fix that. And that looks like I actually would have been adding 4. So let's try it again. Negative 18 minus a negative 22 is a double negative, which means I have a 4. One more time, negative 14 minus a negative 18 is a double negative, and it gives me 4. Since I'm adding the same each time, yes, this one is arithmetic. All right, so find the next 4 terms of an arithmetic sequence. Basically, what I'm going to do is just find what is the common difference from 9.5 to 11. If I need to, I can do 11 minus 9.5, find out that I'm adding 1.5 each time. You might just kind of do a quick check, but if they tell you the next 4 terms of the arithmetic sequence, they're guaranteeing me already that this will be the same each time. So my common difference is 1.5. Great. Add that to 14. 14 plus 1.5 is 15.5. 15.5 plus 1.5 is 17. Plus 1.5 is 18.5. Plus 0.5 is 20. Okay, I can continue that pattern for as long as they say. Here they just wanted 4 terms, so that's all the farther I went. That's not so bad if they just ask me, for the next 4 terms, or even if they had said, how about the next, the 10th term or something like that. The way I can label those, let's get a color switch here. The way I'm going to label those is by doing A sub 1. That means term 1. I don't really know why we use an A, but we do. If you see A2, that means the second term. A3, A4, you get the idea. I can label for as many terms as we have. A7, A8. Where things are going to get a little dicey is if they say, hey, what about A to the 15th? Well, that's not so bad. Like, I can keep adding. But on your homework, it's going to ask you for a, I'm sorry, those shouldn't be equal signs, should they? Let me try that again. 15 should have been written here. On your homework, they're going to say, actually, I want to know a of 74, the 74th term. That's going to be a lot of adding, and I hope you keep track. It turns out what I can do is actually write an equation. And so here is the fancy-pantsy formula that we will be using for that, right there. You're only going to be plugging in for two terms. You're going to plug in for A1 and for D. Remember that A1 is the first term, and D is the common difference. So if I'm given a pattern here, I'm going to go ahead and label A1. Again, it's just the very first one they give me. And it looks like, if I do my negative 10 minus 3, my common difference is negative 13. Plug those in. A sub n equals A1 you said was 3. You're just going to leave A in and the n. Common difference is negative 13. I want you to go ahead and simplify this. It's going to be the exact same steps every single time because it's always going to be set up the same. First distribute. So 3 plus negative 13n plus 13. Then combine like terms. I'm going to pull this to the side here. That's going to be A sub n equals 16 minus 13n. Exact same every time. Distribute, combine like terms, circle your answer. Notice I didn't do anything with this A sub n. It stays. I am going to get to use it a little bit here now where it says, hey, plug in the 15th term. All right, I'm going to come over here and plug in 15 everywhere I see an n. So what that's going to look like is A 15, 16 minus 13 times 15. And I'm going to figure out my calculator. 13 times 15, sorry for that little squeak there, is 195. And now 16 minus my 195 is going to be negative 179. Now what happens with my A15 on the other side? The answer is nothing. Here's what that means. It means, hey, I have the 15th term and it equals negative 179. That's what that 15 means. Think kind of back to when I had, f of x equaled, some function, doesn't really matter, and then I said, hey, f of 3 equaled 4. You didn't do anything with that f of 3. That was just information saying, hey, I had a 3, I plugged it in, and the answer was 4. Well, that's the same idea over here. Hey, I had the 15th term, and it equals negative 179. You don't do anything with that a of 15. We can graph this, just so you know, with the common difference, it's going to graph to be linear. Again, linear means a straight line. Without going too crazy here, it would look something like this. You're not going to be asked to graph it on your homework, so I'm not going to stress it here. And that's all that we're going to work on for today. It is a couple sections on Delta Math.